There's a lot of information today when it comes to circumcenters and incenters. Okay? So, your circumcenter, first of all, is what we're going to get first, is where the perpendicular bisectors, remember we talked about those on Monday, right? So the perpendicular bisectors of the sides of the triangle intersect at the circumcenter. So all my perpendicular bisectors, so perpendicular bisector here, perpendicular bisector here, perpendicular bisector here, they all intersect in what we call the circumcenter. Okay? The circumcenter is equidistant from the vertices of the triangle. Okay? So, if we're talking perpendicular bisectors, first of all, we need to list our perpendicular bisectors. So, my first perpendicular bisector, let's go with this guy right here, it's called DP. So, DP is the perpendicular bisector. Somebody else give me one. FP would be one, yep. FP is a perpendicular bisector, and what else? PE is our third one. What is our circumcenter? Point P, yes, because it's just a point. All right, so we have a whole load of congruent segments. Because first of all, we have perpendicular bisectors, right? So if we're going off of DP, what are my congruent segments on that side? So AB is going to be congruent to DB. If we're going from FP, what do I have? AF is going to be congruent to FC. And if I'm going from PE, what do I have? DE is going to be congruent to EC. Now, this is the kind of the important part that we're talking about when we're talking about circumcenters. Okay? It says that that the circumcenter, so point P, is equidistant. So what's that equidistant mean? Equal distance, yep, from the vertices of the triangle. Okay, so now there's going to be three segments that are congruent to each other. And it's from point P to the vertices of each triangle. Or of this triangle. So P who? P who? PB is going to be congruent to PA is going to be congruent to PC. So from the circumcenter to each vertex. So PA, this guy right here, from the circumcenter to the vertex. PB, circumcenter to the vertex. And PC, circumcenter to the vertex. Those three lines are going to be congruent. So far, so good? All right, so if we look at number one, it says Z is the circumcenter of TUV. So Z is my circumcenter, right? Okay, so TU, okay, so remember, everything is all these little segments are what? Perpendicular bisectors. So perpendicular meaning that they all form right angles. Bisector meaning they cut each segment in half. So if XU is 19, what's TU? 38. Yep, got to double it. Because if XU is 19, TX is 19, the whole thing is going to be 38. All right, so if VU is 34, what's V what? 17, all right. So it cuts it in half. So that's 17, that's 17. Now they want UZ. Huh? Why? All right, because ZV, ZU, and ZT all have to be the same, remember. Okay, that's what the circumcenter does. So UZ is going to be 21. So then it wants WV. Huh? How? Well, XU, because remember we want WV is over here. So we don't know if those are congruent. We know that TW and WV will be congruent. And the triangle do I have? All right, triangle. Do I have two sides of my right triangle? So do I have enough information to use my third? I will tell you in almost every problem you will have to use, what's it called? Pythagorean theorem at some point. So in this case, part B, how am I going to set it up? Squared plus x squared equals 21 squared. This is where I need your help. 15 squared is 225 plus x squared equals 449. 441. Now subtract x squared equals 216. Square root it. X is 14.7. So WD is 14.7. This guy's 14.7. So then they want TV, they want the whole thing. So what do I have to do with 14.7? Double it and get, come on, fill me out, guys. 29.4. Okay, we can use everybody's participation. It won't hurt us to answer a question. Okay, horrible? No, but you gotta know some stuff, right? Alright, so let's look at number 2. Alright, so GD. Okay, so the whole thing it tells us is 24. So GD is 12. Because we've got perpendicular bisectors. So bisects it and they form right angles. That's important to know that those form right angles because you're going to have to use right triangle. Okay, BC. If CE is 7, BC is going to be, well, BE is going to be 7, but what's BC going to be? 14. EH, eventually, yep. Okay, so if we look at this, what are my congruent parts? BH, right? HEN. HC, right? Those two are congruent. So BH is 13. What's CH? 13. Actually, I didn't even have to go over there. I could find BH with this guy, right? Yes? No? Well, it's big. It will help you learn to participate. Alright, so part C, we have to use, I was told we have to use figure theorem. I'm going to set them up. Huh?
7 squared.
Okay, so what's 7 squared?
49.
49 plus
X
x squared equals
13 squared.
13 squared is 169, okay? So you guys have to start training yourself. You're gonna, I believe, have to know next year your perfect square is up to 15 at least. Okay, so that's, so 13 squared, you gotta know it's 169. So x squared is 120. So x is 10.9. Alright. So EH 10.9. FD. I don't know if there's more to find FD. What's HD? What's HD? 13. This is equidistant, so it's the same as VH. So to find FD, I've got to use old Pythagorean again. So how am I setting them up? Which is 9 plus x squared equals 169. So x squared is 160. FD is 4.6. So CD is fine. You should all have your calculators out. It's a requirement to bring a calculator to class. What? 25.2. Okay, you are required to bring a calculator to class. I'm not sure why half of us don't have it out. We have to start taking grades to see who actually brings their supplies to class. Alright, so circumcenter is perpendicular bisectors, right? Alright, so the incenter is where the angle bisectors of the angles intersect at point. The incenter, okay, which is point what? P. Right? The incenter is equidistant from the sides of the triangle. Okay, so circumcenter, I was talking about the segment that went from vertex to circumcenter, right? When I'm talking incenter, I'm talking segment from incenter to the side to where it makes a right angle to the side. Okay, so P, P, and FP. And what do I mean when I'm talking about an angle bisector? Bisects the angle, what does that mean? That it bisects the angle. Cuts the angle in half, yep. And if you're not going to participate, I'm not just going to stand up here and talk to myself. Seriously. Like, you got to be able to open your mouths and do something. Because right now I feel like I'm talking to like 3 people in the room. Right? You got to help me out here. Right? So my congruent segments of this are, what are my 3 big ones that I want to talk about? VP is congruent to PE is congruent to, yeah. Alright, so in number 1, what's NP? 8. Alright, so now one's NK. How can I find NK? Where do you, so I have 8 up here. This hypotenuse is 13. I don't know what that hypotenuse is. Only a circumcenter, but this is an incenter. What else do I know up here? What else do we know? What else can I fill in?
By doing finding the hypotenuse of your face.
Okay, how are you going to find the hypotenuse tool? Only on one side of that triangle.
DL is 8.
Okay, thank you. DL is 8. Why do we know that DL is 8? Because that's an incenter, yeah. Those 3 segments are all going to be 8. Okay, you guys are going to have a lot of time to work on your assignment if we're not, like, honestly. Alright, so, now somebody wants to find P or PK. Okay, so we can go ahead and do that. How are we going to find PK? What? So what are we using? The Pythagorean theorem, good. So I'm hearing some people set it up, which is 17 squared, which is 3 what? 289 plus 64 equals BK squared. So when I add those together, I get 353 equals PK squared. So PK is what? 18.8. Okay, so now do we have enough information to find NK, Morgan? Well, we gotta find out. We can't just assume that though. Okay? So what do we have to do now? Pythagorean theorem. Okay, so B, oh no, this is part B. 64 plus, NK squared, yep, equals 18.8 squared, which is what? 353.4. Alright, so subtract your x squared, or subtract your 64, x squared is? Oh, 289, so x is? Morgan, you had a hunch that it was 17. What? Kind of. I like where you're going with it. Okay, so remember back on Monday, if this is an angle bisector, what do I know about these two sides? 17 and 17. So that's why it makes it 17. Okay, but we also found it using the Pythagorean theorem, so that's good. Okay, now how am I going to have to find that out? Do I know ML? No. So what am I gonna have to use? Same as here. Okay, so B. How am I gonna do this? 64 plus x squared equals 169. X squared is 105. So LO is all right. So right off the bat. All right. So number 2, how am I going to find G? I gotta use figures here because I do I know any of these 3? No, so I gotta find it. So what's 35 squared? What? You gotta say it louder and don't mumble it. 8 plus x squared equals. Thank you. X squared equals. 144 exactly? Alright, so GD is 12. Good. So this guy's 12. BG, where's BG? This guy right here. Okay, so if GD is 12, what's EG? 12. How am I going to find EG? Oh, this is a lot here. Good thing we did it yesterday, huh? Alright, so how am I set this up? What? Oh yeah, 36 go up. Hey, but that's what I like. I like that you guys corrected us. That's excellent. That means that we're actually participating. No confused. This guy, this little triangle right here. Okay, so I add those together, I get 180 equals x squared. So BG is 13.4. 13.4. FC. Oh my gosh. What's FG? 12. So we use the figures here, we get to find FC. If D is 6, oh, actually we don't have to. What's CD? 35. So FC has to be 35. 35, yes. I always forget to look at that property. How about if BE is 6, what's BF got to be? 6. Okay. Your assignment has way more algebra on it, and I would